Hello, I'm George Borelli, Crystal River, Florida. I'm working on mid 70s cruise control made by Chrysler. I'm going to go over where we are and learn a little bit about it. Okay. Okay, so here's cruise control in pieces. On this side is what I would have called the vacuum servo. On many other systems, they're usually separate, but it's incorporated, has a rubber seal. If there's a vacuum, it pulls in, and the release vacuum, it pushes out. That's connected to a cable. The cable's connected to the carburetor. Sometimes the rubber goes bad, the seals go bad, so you have to check the integrity to make sure there's no leaks. That's not the complicated part. Complicated parts are in here. But on this end is the speed governor. Typical of the era, they use flyweights, so as the centrifugal force goes out, it pushes these weights out and has levers, and levers push a piece out through the center. That in turn pushes on this side. There's a low speed switch in here, and this one is broken, I discovered. It goes right in here. But it turns out that controls one of the solenoids grounds. So with the customer's permission, I bypassed the low speed. So this thing will, if you do it, will try to cruise at a speed that it's not designed to. It's not particularly dangerous, but it could jerk the car around or not cruise correctly. The cruise controls this era are supposed to be cruising, almost all of them would start cruising until 30 miles an hour. At 30 miles an hour, these weights push out, push the pin down, the pin pushes this, and then this clicks this device and it puts a ground connection here. What I ended up doing was bypassing the ground switch, routed it to a ground that already exists, and soldered it together, essentially a jumper, a ground jumper. So that was the first major problem. This wouldn't run without that. Then I tested the functions of the two solenoids. This is what they call the brake vent release solenoid. Sometimes they call it the holding solenoid. That there drives a plunger over here. When the plunger has no power, it's normally sprung loaded open. So that means the ambient air can get in, and with the ambient air inside this body, there's no vacuum to pull this rubber, and so there's no acceleration. To test that, you have to go to these connectors. There's 3 connectors on the system, 1, 2, and 3. I have a harness that I bought with the system, and I use it for testing. What's notorious on these things is these are terrible design for a rough environment, but they get oxidized and they don't work anymore. But this connector slips over the top of these 2 connectors here, and they get oxidized, but worse, this gets oxidized. Also notice a looseness in this. You gotta make sure these guys are tight. They're tightened by these, the bolt goes through, there's a nut where there's the wire connector. For testing, you put power on this terminal and power on this terminal. This terminal represents the momentary switch to engage or set the speed. It's a little complicated on the push button on the directional signal. I could cover it, but it might not in this video. This is the port, the vacuum from the intake manifold of the car. That's the moving power that it needs. That goes inside, and it's modulated by speed by this cover plate. This cover plate is a thin, it's copper or maybe brass, flat plate. It looks like it's pretty highly machined. Fits over the top of the inside of the plenum and covers it. So when the speed is, when you set it, this is the other device. This is the locking mechanism. So this solenoid will pin this centerpiece to this end, moving up and down. So as you move this up and down, that moves in and out. But when it's pinned, it also moves this. What do you call it? This vacuum cover. So it lets vacuum in and out, in and out, in and out, depending on speed. If speed goes too fast, it'll push this open, and it'll push this down, push this open. Once this is locked, and it'll or too slow, it'll let more vacuum in. If it's too slow, it'll let less vacuum in. When the system shuts down, when you step on the brake, it completely dumps all the vacuum to ambient through a port behind this guy. That's another solenoid. That port is here, and it's normally hidden under this cover, and under the cover is a filter. And all these cars from this era, the filters go bad. The nice thing about this design is the filtered material doesn't fall inside the works. And the GM designs, a lot of them, the filters disintegrate and they get inside the works and gum up the works. This thing, I think I got it working at the electrical and mechanical level. The vacuum, we're going to have to build some sort of a seal for this. This needs to be high integrity seal. And then this one here needs to be high integrity, as covered by the rubber. I think I'll stop at that point. You should also check, make sure that this is working correctly. Maybe a very light grease could go in here, something that doesn't affect the plastics. It's good to see the plastics are still healthy. This here is a mainspring that goes against this puller, and so the spring will tend to push it out all the way, so that would be idle, and then the vacuum will pull in against the spring, and there's a long cable connected to your carburetor that makes that all work. I noticed in this one too, there was a part missing. Someone's been in this before. It's not a significant piece, but everything has a purpose. So I kind of machined one. It's supposed to sit here. It's a funny way of holding down the gear, but I think it might be important, so I made one up, because when you screw on the source, speed source, which is from the transmission, it could push this in too much, and that could cause a problem on the inside, so we probably should have that in there. This is a reduction gear for the speedometer cable. This goes out to the speedometer cable. This end looks like they don't usually go too bad. Looks like these are pretty solid. I'm surprised that the plastics have held up so well all these years. A lot of other systems that work on the plastics disintegrate. Where you're going to have problems are more on this end. The notorious low-speed switch will fail, and I really don't know how to make up one. It's a really funky design, so I think you could bypass it if you want to. You could do some measurements at your own risk, bypassing anything at your own risk. That part, and then over here, the solenoids all have to work correctly. It looks like, for the most part, they're pretty rugged and durable and reliable. Where it goes wrong, which is typical, is the oxidation on the connectors, and maybe the switches on the turn signal switch as well. There's no adjustments on this switch, on this thing to speak of, except this thing. They recommend against playing with it. I think you can dial in the rate at which the vacuum will move the diaphragm. This solenoid is the locking solenoid, locks that bar. I think it covered that already. Okay, I'm actually not sure what this device does, but looks like it's pretty hardy. Looks like it's some kind of feedback loop for the movement. But as long as it's intact, it should work okay. So now that I've completely tested both solenoids, all the functions, found this broken switch, came up with a workaround, I'm going to put it back together and attempt to test the seal, make sure it's sealed tightly. Okay, that's it for now. If you need help with your cruise control systems from the 50s, 60s, or 70s, look me up, George Borelli in Crystal River, Florida. Thank you. Oh, please like and like and subscribe.